Okay, it is time to start stoichiometry. We are going to start with gravimetric stoichiometry, which is basically math that involves mass, grams. To get there, though, we're going to start with some very easy problems where we're just moving moles to moles. So this is the first, there's 3 of these lessons I've put in the plan for today. You don't have to watch them all today on Friday, but I'm just getting them out there for people that want to go through all. Maybe like you're binge watching. No, that's terrible content for binge watching. Okay. So there are a series of steps for stoichiometry problems. And first off, what is stoichiometry? Well, one of the cool things about stoichiometry, just to explain in a nutshell, is I'm going to use this very famous reaction. Stoichiometry is incredibly cool because compounds in balanced reactions combine in set amounts of ratios. If you were to weigh out, I know this is a gas, but let's just pretend. If you were to weigh out 10 grams of nitrogen, by the end of today, if you watch all the lessons, or by Monday, you would be able to predict exactly how many grams of ammonia you would make. And that goes for, we're eventually going to talk about gas. You could predict the volume. You could also predict the temperature. You could predict in solutions the concentration. So stoichiometry is one of the most powerful things in chemistry because it allows us to start with a material and know with like 100% accuracy, if our lab skills are up to snuff, how much we would actually get in the end. Now, why is that important? This reaction changed. This is just a really famous quick reaction because it's easy for me to write. This reaction changed agriculture. It allowed farmers during World War I, World War II times to make more food than they normally would be able to feed the population. This is how fertilizer was made, so they could, have greater crop yields. So they would know exactly how much nitrogen to put in to get an exactly amount of ammonia out, which could then go on to make different types of fertilizers. You could think of this as gold. Like if you don't want to randomly do a reaction, I mean, you can, it's fun, but then you'd have to, randomly get a product you wouldn't know. All right. So I'm going to go through this. The first video is going to have the steps. Every time I do a reaction, stoichiometry goes through all of these same steps. And this is true for all types of stoichiometry. The first step, so important, write a balanced reaction. Include all of your states. So make sure that first reaction is perfect because everything goes wrong if that reaction is not correct. Okay, first step. No matter the type of stoich, you need a balanced reaction. Okay, second step. I am going to be painstakingly writing down everything I know about the question because we're going to be using those different those different mathematical values. I call them variables. They're not really variables, but I'm going to call them variables from now on because we're going to be using those in unit analysis. Whatever the question asks us to solve for, that's the thing that we need to be laser focused on getting in our unit analysis. So if the question wants us to solve for grams of a substance, I need to make sure I end up with grams of that substance. The other thing is you probably for every question you're going to need that fraction of mole ratio because we're always comparing 2 substances. So that little video from Thursday, that's why I showed it to you guys, because I'm going to assume you've watched that, and when I say this is the mole ratio, you'll know what I'm talking about when we're comparing 2 substances. Okay. And lastly, we've used dimensional analysis or unit analysis before. We're going to cancel out everything we don't need until we wind up with the thing that we do. Now, today's lesson is on mole to mole. These are the simplest stoichiometry reactions, okay? So I'm going to bore some of you. You're going to get it right away, and you're going to wish there was a faster way to do it. I'm going to do it the slowest way possible to show the proper steps. The second video and the third video today are, and if you don't want to watch them, you can watch them Monday. They're going to get a little tougher with more variables. Okay. Now, the last thing I'm going to say, it doesn't apply to this video because we're not using mass, is that if a substance is given to you and it gives you the mass, or you're asked to solve for mass of a substance, you need that substance's molar mass. Mass and molar mass go together because it may be the only way you can solve for grams or cancel out moles. Remember, mass variable is grams, molar mass is grams per mole. Okay, let's try the first one. So mole to mole reactions are the easiest, but some kids forget how to do them and they try too hard. So here's the first reaction. This one, everything is balanced, everything is given to you, okay? So it says if 14.7 moles, you know, I'm just going to move, I'm going to change this around so it kind of looks like the note pack that goes with this. Here we go. So if 14.7 moles of calcium fluoride react, how many moles of sodium fluoride are created? So the first thing we're going to do is we're going to link the two substances the question's talking about calcium fluoride and sodium fluoride. Okay, there's calcium fluoride, there's sodium fluoride. So guess what? This question is not talking about sodium chloride and it's not talking about calcium chloride. They are not important to this problem at all. Okay, now let's write down everything we know. We know we have 14.7 moles of calcium fluoride. That's what it says, right? 14.7 moles calcium fluoride. It's asking us to solve for moles of sodium fluoride. So I'm going to go question mark, mole, sodium fluoride. Now, the last thing I'm going to write down, and what I'm doing is I'm writing down we've done this before, where we made a toolbox, but I'm writing down the math that belongs to the compound underneath of it. You could do all of this in a little box on the side. That's fine too. You could go like 14.7 mole and then question mark mole. I like putting it below the thing in the balanced reaction. Now, the second thing that I forgot, the other thing I forgot to write down that's important is every Stoich problem needs the mole ratio. And the mole ratio here is 1 mole of calcium fluoride for every 2 mole of sodium fluoride. It's so important, I put it in a box. So you don't have to put the mole ratio in a box, and it doesn't matter which one you write first. Okay, so this question is going to be over really fast. Some of you who are good at math probably see the writing on the wall, but we're going to use unit analysis to cancel it. This question wants us to solve for moles of sodium fluoride. So I need to find moles sodium fluoride. Is that mole sodium fluoride? Nope. There it is. That's mole sodium fluoride. But guess what? It's on the bottom of the fraction. So you can flip mole ratio. Okay, so I'm going to go 2 mole sodium fluoride. I'm going to start with the variable on top that I need to answer the question. Okay, once you use a variable, it's gone. Can't use it again. Now, I need to get rid of calcium fluoride. You guys see the calcium fluoride right there? So I can get rid of moles calcium fluoride by putting this whole thing on top of the next fraction. I'm just going to shrink my box here a little bit. Okay, so my next bracket will have 14.7 mole calcium fluoride on top over 1. And the rate that cancels. So yes, I am just timesing it by 2. So we did all that work just to times it by 2. Round to 3 sig figs. I get, what is that, 29.4. Okay, so a mole-to-mole question is literally just timesing the moles you're given by the proper mole ratio. That's all it is. But you have to make sure your units cancel. It's very easy. We're going to try one more. Okay, so this one says 3 moles of silver metal react with magnesium nitrate in solution. What moles of magnesium will be produced? So a little bit tougher. We're not given a reaction here. We have to write it out. Okay, silver metal is a solid. Magnesium nitrate, it says it is aqueous. Nitrate is 2, or nitrate's 1 negative, magnesium's 2 plus. This looks like a single replacement, so the magnesium gets debunked. And we wind up with silver nitrate. Now we know that silver nitrate, because we have an aqueous substance here, this one we need to check our solubility table, but it's always soluble with nitrate. Balancing this, we need a 2 there and a 2 there to balance out the nitrate's rate in the magnesium substance. Okay. All right, let's write down what we know. It says we have 3 moles of silver. It wants us to find moles of magnesium, question mark, mole magnesium. And what are we comparing? These 2 substances. So I need to write down 2 moles silver over 1 mole magnesium. This is the mole ratio, so important. Okay, the question wants me to solve for moles of magnesium. That's what it wants me to solve for. So I need to find moles of magnesium. Nope, nope, there they are right there. Oh no, they're on the bottom. Oop, whoop, what just happened? Okay. Oh no, they're on the bottom. I guess I could have been smarter and started with that ratio flipped. But guess what? I can flip a fraction with unit analysis to suit my every need. So I'm going to flip that to get moles of magnesium on top. Yay, right? Because that's what I'm solving for. That's what I've got on top. That's gone. Once you use it, you use something, you can't use it again. And then times that by 3 mole silver over 1. Moles cancel. So yes, because if we look at this, we're going from 2 to 1, and that's a half. So it's 1.5. Yes, math people, I feel your grouchiness. Now you'll see in the second video, as soon as we add mass, you can't just decide to use mole ratio to decide new masses. It doesn't work that way. It's a little bit tougher. So that's the first lesson. This is on mole to mole.